In this learning target, we're going to talk about adding and subtracting polynomials. This is really kind of a fancy way of combining like terms, but a lot of times we're trying to add one polynomial to another, so we're using parentheses. So I'm going to talk about adding polynomials first. It's a little bit easier than subtracting. And there's two methods that you can use to do this. The horizontal method is basically where you can write all the terms out and then combine like terms. So when I see two polynomials added together with parentheses, if they're added together, oops, let me get my pen working here. If there's a plus sign here, you can just drop the parentheses. So I'm just going to rewrite this, 5x squared plus 2x minus 1, and then just carry the other polynomial over. And then to combine like terms, I like to use shapes, so I'm going to circle or put a square on the similar terms. And we want to write it in standard form, so I'm going to pick the highest degree first to combine. So that's the x squared terms. So 5x squared and 4x squared is going to be 9x squared. And then I'm going to cross them off so I know that I've used them. Then I have 2x and negative 1x. 2 minus 1 is 1, so this term just becomes x. Cross it off. And then I've got this negative 1 and 2, which gives me a plus 1. It's in standard form, so I know I've finished my problem. That's the horizontal method. The vertical method is where we line these up old school style, like elementary school. So I'm going to take this first polynomial, 5x squared plus 2x minus 1, and I'm going to put a plus sign here, and then write this next one right underneath it, and I'm going to match terms. So the 4x squared goes under the 5x squared, the negative x goes underneath the 2x, and this plus 2 goes underneath the 1. And now I just add them like I would any other addition problem. 5 plus 4 gives me 9x squared, negative 2 minus this 1 gives me positive 1, and negative 1 plus 2 gives me a positive 1. And I end up getting the same answer as I get with the horizontal method. It's just a different way to look at the problem. Ultimately, I don't particularly care how you do it. Whatever works for you in your mind. It's fine with me. Let's take a look at another example that's a little bit different. Here I've got a polynomial times a trinomial plus a binomial. So I'm going to do the horizontal method here and just rewrite and drop the parentheses. And now I'm going to look for like terms. I'm going to start off with this highest degree right here. And I notice there's no other like terms with the third, so I'm just going to rewrite it. The next one is this y squared, and again I notice there's no other like terms with the y squared, so I'm going to rewrite it. And then I've got this 2y, also no like terms, so I'm just going to put plus 2y. And the only things I can combine is this 1 minus 1, but they cancel out to 0, so I end up getting this for my answer. It's okay if you have terms that don't combine, right? We're just trying to simplify the expression. Now the vertical method's a little harder for this problem because when I first write this 3y to the third, I'm missing the y squared term. There's no y squared, right? Where is it? It's not there. So when you're missing a term with the vertical method, you actually have to write it in with a 0. Because otherwise the terms won't line up, which is sometimes hard to remember. So this is one case where I think the horizontal is easier because lining these up can be tricky. Now when I do y squared minus 1, I'm going to put the y squared here and the minus 1 here, and then just bring the stuff down that doesn't line up. So I get 3y to the third. 0 plus 1 is 1, so this stays y squared. The 2y comes down, and then 1 minus 1 is 0. So again, I still get the same answer, but that's only because I lined them up correctly. So that's the only tricky part about the vertical method, is making sure you line it up. What about adding polynomials with two variables as terms? No different, it just might take you a little bit longer and being a little bit more careful. So I'm going to go ahead and do this horizontally. I prefer horizontal, especially because lining up the terms can be hard, but I'm going to leave that up to you guys. So I'm going to rewrite this, 7qr squared plus 6qr squared plus 21q, drop the parentheses, plus negative qr squared minus qr squared minus 11q minus 3 q to the third r to the squared. Finding like terms here is a little trickier. I'm going to start off with my highest degree alpha order, which is this guy over here. Okay, that's a q to the third. I don't see any other q to the thirds, so I'm going to write that one first. Negative 3 q to the third r squared. I also recommend in class using colored pencils to mark your like terms. It makes it much more easier. You're less likely to forget something. Now I'm going to look for any q squareds. I don't see any q squareds, so I'm going to go down to the next degree, which is q's. So just, excuse me, just q's by themselves, which is right here, 21q and negative 11q. 21q minus 11q gives me a plus 10q. Those are done now. And now all the terms left are this qr squared combo. Oh, I've made a mistake. I have made a mistake, guys. I copied it down wrong. This should be a q to the third. See how easy it is to make a mistake here? So that actually changes things, because now this guy, this negative 3 q to the third r to the squared, actually has a like term here. So that wouldn't be a negative 3 anymore. This would be a 4. Okay, so it's very easy to make a mistake. You just saw me do that, and that wasn't even on purpose. That was just me not paying attention. Okay, now I've got these guys left, the 6qr squared minus 6qr squared and minus qr squared. Well, these two guys go out to 0, so they're done. So I'm just left with the minus qr squared. This is in standard form, alpha order, largest degree to smallest degree, so be careful about that. I will be checking that. Let's take a look at a language problem. A farmer must add the areas, I'm going to put a plus sign, of 2 plots of land to determine the amount of seed to plant. The area of A can be represented by this polynomial, and the area of B can be represented by this polynomial. Write a polynomial that represents the total area of both. So they just want us to add these two together. So I'm going to write 3x squared plus 7x minus 5. I notice that both of them have the same terms, so I'm going to use the vertical method and just write them underneath each other. Then I get 8x squared plus 3x plus 6 as my new polynomial for the plot of land. Okay. This next question is, the sum of 2 polynomials always another polynomial? The answer to this question is absolutely a yes, except for one thing. If all terms cancel out. Meaning, if I have like y squared plus 3 plus x squared minus 3, when I simplify this, this cancels out, this cancels out, this cancels out, this cancels out, and nothing's left. So then the polynomial just disappears. So that's the only time that it wouldn't be another polynomial. Okay? Let's take a look at subtraction, because subtraction adds a different level to it. And there's something we have to think about, and that's signs. Because subtraction involves a negative sign, and so we have to be really careful with that. So the horizontal method is identical to adding, except you can't just drop the parentheses. This minus sign, you have to distribute. This is like a little invisible -1, and you have to distribute that to everything inside. So you can bring down the first polynomial, but then the second one, every sign inside is going to change. -1 times -2 makes this a positive 2x squared. -1 times -3 makes this a positive 3x. And -1 times positive 4 is -4. So in general, all the signs just switch when you subtract for the second polynomial. And now you just treat this the same. You just combine like terms. So I've got 2x squared, and then I've got 5x and 3x to give me 8x, and then I've got 2 minus 4 to give me -2. Vertical method is the same. I've got 5x plus 2. Now we put a minus instead of a plus. I've got a -2x squared, and that doesn't go with anything. There's no other x squared, so I'm going to put that under here. Okay, that's like a 0x squared right here. Is one way to think about it. Put your minus sign, minus 3x plus 4. Okay, now when you combine this, you're going to have 0 minus minus, so this becomes a plus, and you've got 2x squared. 5 minus minus, this becomes a plus, and you've got 8x, and then 2 minus 4 is negative 2. Still the same answer, but just a little bit tricky in terms of lining up and in terms of making sure your signs are correct. Okay, let's try another. Okay, letter B. I'm going to make my invisible 1, distribute to what's inside. I get y squared plus y minus 1. And then negative times a negative is a positive 2y squared. This becomes negative y, and this becomes negative 1. Combine like terms, 2y squared and 1y squared gives me 3y squared. The y minus y goes away because they cancel out, and negative 1 and negative 1 give me negative 2. The vertical method, same thing, y plus y minus 1, put your subtraction sign, negative 2y squared plus y plus 1. Y minus a negative gives me a plus, so I get 3y squared. Y minus y cancels out to 0, so those are gone. And negative 1 minus 1 is still negative 2. Okay. What about polynomials with two variables? No different. We distribute. We just need to be careful. Okay. I'm going to write this correctly this time. Okay, minus 21q. Then all of these signs change to positive because they're all negative. So this is going to become plus qr squared plus 6qr squared plus 11q plus 3q cubed r squared. Now I'm going to combine like terms. I'm going to start with my q to the thirds here. So there's 1 and there's 1. 3 plus, there's an invisible 1 here. That gives me 4q to the third r squared, and then I cross off so I remember I don't need to do them. I don't see any q squared, so I'm going to go straight to the q's. That's a negative 21q and a plus 11q, so that gives me minus 10q. And then finally we'll end with the qr squared. So that negative 6 and that 6 cancel out, and so I'm just left with the qr squared left over. Again, needs to be in standard form. Okay. Let's check out what a word problem might look like here. The number of gallons of water leaking in a leaking pool is determined by the rate the water is filling and the rate the water leaks. Okay, where G represents gallons entering or leaving the pool per minute. Write an expression for the net change in gallons. Find the change in the amount when the rate G is 5 gallons per minute. So when I hear this word leaking, I think subtraction, right? Something is going away. So I've got my two trinomials here, 8g squared plus 3g minus 4, and I'm going to subtract what it's leaking. So that's a 9g squared minus 2g minus 5. Now I'm just going to subtract. 8 minus 9 is negative. I've got two negatives here, so that becomes a plus, so plus 5g. And then this also becomes a plus. Negative 4 plus 5 is 1. Okay. Now it wants me to see when the rate is 5. So this means I'm going to have to plug in 5. Which is no big deal. I'm going to use parentheses, plug in 5 for G. Negative 5 squared, this becomes negative 25, plus 25, and then plus 1. These cancel out, so my rate is 1 gallon per minute. Not so bad. Is the difference of two polynomials always another polynomial? The answer to this is still a yes, except when, again, it cancels to 0. Okay, so this learning target's not so bad. You just have to be careful. You saw me make a mistake, so very possible you can make a mistake. Just be careful, use colored pencils, highlighters, whatever you need, and ask for help if you need it. Good luck.